Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the C++ series. In this lesson, we're going to be talking about the vtable. So this is something that's come up when we've talked about virtual functions, virtual destructors, and we're going to also have to talk about once we get to multiple inheritance. But with that said, let's go ahead and take a step back and just understand what this data structure is in C++ that enables virtual functions to work as they work. So this lesson, I just want to talk a little bit about the concept of virtual table. So we've been working with these examples where I have a base class and then a derived class from that base one. And from this derived class, if I override any of the virtual functions, the appropriate member function will be called when we instantiate some new derived instance of an object here. So that's the idea here. So I'll go ahead and run this one more time. If you haven't seen this previously, from any of the previous lessons, make sure you go ahead back in the series to check those out. So again, just to see what's going on here, we create a base pointer here, and derived is a type of this base class because it's inherited, and we call the member function, and the appropriate derived member function is called because we're able to override this virtual function. So here's what happens, or what's happening in the C++ compiler, or something like this in most C++ compilers. Anytime I use the virtual keyword, a virtual table is being created. So if I go ahead and just draw out these classes, for instance, let's go ahead and just label this one here as the base. And I'll go ahead and create another one here, which is derived. And this represents all the different member functions that we have. So we have our constructor, for instance, our destructor, and that member function here, member func. And I'm just going to put a little annotation next to that one that it's virtual. So V for virtual. And the same thing for our derived class here. And we have the destructor. And then we also have member func here. Now, once I create these particular objects, or rather these types, and anytime I have just one thing marked as virtual, we need a virtual table. So what's going to happen is within this class somewhere in C++, wherever it's being defined, there will be something known as a vtable pointer. And usually this is something, I'm just going to sort of make up the convention here, maybe with two underlines here, but a pointer to some table here. And what that is going to do is have a pointer to, say, the base table here. So when I actually create objects using a pointer here, where I'm dynamically creating these, we're going to look inside of this vtable here for our base object. And it's going to have a list of all the different functions here. So for example, member func would be in this list here somewhere. So we know whenever I have a base object to do a lookup in this table and call the appropriate function. So same thing for derived. I'm going to have a vtable pointer here, and it's going to point to something for the particular derived class here. Derived. And I'm just going to annotate here that this is our vtable here. And when I have member func here, and I apologize for the writing here, let me write it a little bit nicer for you. Member func, I think you get the idea. This is actually going to point to, well, the correct instance of member function for our derived class here. So again, maybe that is saying, hey, point back to, this particular function and make sure that we call this one here. And that's the basic idea of our vtables. So anytime that you have virtual in your classes here, so let me go ahead and just highlight one instance of it at line 10 in our code, a vtable is created. So that's what's shown here on the right. And then within our class, we also need a little bit of storage for some pointer to this actual table here so that we can call the right object here. And this is a pretty powerful idea that we have this extra member variable here. Because again, if we look at line 27 here, where I just create this base instance, well, again, it's a pointer to something. And this instance could actually change for example. So let me go ahead and extend our code example here a little bit here. And let me just go ahead and annotate a little bit in text what's happening, just to keep everybody in the same page here. I'm going to make this a little bit bigger because I think we get the idea. But we create a base pointer that can point to base or derived, i.e. anything that is a base, which again is base or the derived class. Okay. Then what happens when we call a function, and I'll annotate just a little bit here, we also have a vtable that is created for this instance of the object. When we call a member function, the vtable points us to the correct member function. And again, we could explicitly, if we want, say, we could change this by sort of overriding that behavior, but the vtable is going to point to the right thing, which in this case is the derived member function. Okay. And then let's say that we delete the instance. So that's going to delete this memory. Now let's say we go ahead and reinstantiate this instance and do new base here. And now if I do base member func, let's go ahead and see what happens here. And I'll also want to delete our instance again, just so we don't have any memory leaks. So the first time when we're pointing with our pointer to derived, we're pointing to or allocating memory for derived, calling all the appropriate constructors, eventually all the appropriate destructors. Again, from our last video, we learned why we make the base destructor virtual. And then we also have this internal tiny 4 bytes or maybe 8 bytes, depending on your architecture, pointer to a vtable. And then when I delete this, I can, well, create a new object here. And then now base, the vtable pointer will be updated, and now it's going to act like a base object. So let's go ahead and recompile this over here. And I'll just move this here, recompile. And oops, I need to actually call this as instance here. Again, as being just very explicit. I'll recompile, rerun, and then we can see that the second time after we construct our object here, we're just calling, well, one constructor because it's just the base object, the correct member function, and the correct instance. And again, you can think about this as, repointing to the right object. In fact, another way to do this is if I'm, I don't even have to go as far as deleting this. If I just had this pointer and was pointing to different objects, we would be able to say, okay, what within this derived object is the vtable pointing to? And again, the derived object has its own vtable that always points to or stores the member function that'll tell us which member function to call here. So that's what's going on in this code and what this internal vtable data structure is. Now, when we get to multiple inheritance, that is, if I have 2 classes that I am inheriting from, we still have this sort of vtable here. It gets a little bit more complicated because, well, we have to, again, figure out which actual member function is going to be called, and there's different tricks we can use with virtual inheritance and so on, but we'll have to get to that in a future video. So folks, I hope this is a useful lesson. I hope this sort of clears up what is going on, this sort of mythical vtable that you might have heard of before, and being able to draw out or just understand that there's some sort of pointer that's being stored within our class once we use that virtual keyword is an important thing. I think a lot of folks who are going through C++ interviews will be asked about this, and you should have some description or understanding of what's going on within the system in order to truly understand what's going on with inheritance. It'll help you to debug your code, it'll help you write better C++, and just be a better programmer in general. So I hope that was useful. Go ahead and give this video a like if you thought it was useful, subscribe so you don't miss other lessons, and of course comment below if something was confusing and I can help clear it up. All right, thanks for your time, folks, and we'll see you in the next one.